Actually, today we are going to see the. Today also it's a in a small concept only. Small mean in fundamental concept. Mostly next week onwards we are started to seeing the architectural concept. Okay, so this week we are going to see. I think most of the people know this concept. This is a fundamental. Just recalling purpose. Please listen again one time. Okay, so first we are focusing on the type qualifier. So different type. First is the const. Different cases, totally 4 cases we have. So that 4 different cases we will see, how the const is working. Then we have the volatile keyword. For understanding the volatile, we have to understand the compiler optimization. Is my voice is clear, or along with the fan noise also is coming? It's clear, right? You're not getting any fan noise.
It's clear, sir.
Okay. So then compiler optimization, we have to see that one different optimization level. Then now that volatile reflecting here, that we have to see. Third important one, preprocessor. Preprocessor directivities, hash if, and if, how we are using. So error warning, the things we have to learn. Next one, build process. Build process. So what are the stages in build processing? So if you're uploading flash the program, what are the variables is going to store the flash memory, RAM memory, then the make file introduction, linker file introduction. These are all those things we are, practically we will see in our bare metal concept. Separately, we have the 2 classes for these things for understanding. Here we are getting some introduction. That's it. Fifth one, we have to learn. I'm mixing one thing. So directivity, preprocessor directivity, compiler optimization, type qualifier. Fifth one, we have to see one thing.
Typecasting.
Typecasting. Typecasting is easy only, I think. Maybe this 2R is not that much important. We will see. But in third class, we have to cover these fundamentals. If we have the time, we will plan this one, or else we will see the fourth class. Next week, we will see. Next week onwards, we have started to going to see the in-depth concept. Next week, we will see the bit fielding. For that, you have to learn a lot of structure study materials. I will share this week. Okay. So let's go to the concept. First, we will see the const keyword. As I already said, most of the people know this concept, but just say again one time. Let me take for 15 to 30 minutes. This is important. 4 cases. Okay, what is const first? Anybody? Why we are using that const keyword?
For some variables that should not be altered during the program run.
Okay, very good. So for that we are using the const keyword. But we, most of the people know that one. Let me just to do that first thing, simple one. Then we will go to the cases. I think this is the first case. First case we are using the const variable for normal, normal variable. 1 minute. Just emergency calls. Just 1 minute. I'm sorry. Can we start?
Yes, bro.
Okay. So here actually, we can use unsigned CAD. We can use, or else we know, right, that you int 32. That's one. just make it some PTR. That's a normal variable now, okay? Or else let's make the a equal to 10 now. So for this, this already we know that is a type def of some data type. If it is the 8 mean, what is the data type? What is the data type? Unit 8 is representing what is the data type?
Unsigned char.
What is the data type? So we can directly write the unsigned char also, it's fine. But normally we are using like this only. Okay, so which file has this type types? Anybody have idea? Hash
Standard int.
Fine. std int. Okay, that's it. So now this is a normal variable. We if I'm printing now. Here I'm changing that variable. I'll use 50. Then I'm printing. This is the first to print and this is the second print. That's why I'm mentioning first to 2. Okay, this we already know. We are getting first is 10, second is the 20. Anybody have doubt? No, right? Fine. Now come to the const. If I mention const here, what will happen? So here it const mean you should not overwrite. If you're trying to overwrite, then it will give the warning. Not warning, error. You can see it. This is a read-only variable. You can't able to modify this. We clearly know this is a case 1. In this case 1, since it's a local variable, the const variable, since it's a local variable, we can able to modify this data. It is global variable. We can't able to do that. In global variable, if you mention the const, you can't able to do that any changes. Since it's a local variable, we have the one method to overwrite this data. So what is that method? Anybody have idea? How can we change its
Pointer.
data? Pointer. Very good. So using the pointer, we can able to change this one. So same data type, and let's take this one. PTR equal to address of A. So using address of A, using PTR, I can able to change this one. Here I will get some warning for typecasting. That's not a problem. You can see I'm getting some warning, but I will. What's the problem? That is a warning.
Printf is been the typo in the printf.
Then how it's working previously? Previously we did not build, I think. Okay, 1 minute. So actually I'm in some emergency situation. That's why I'm getting call. Just one. I'm really sorry for that. Okay, so this we know. Yeah, if I'm build, I'm getting some warning, but it will work. If you see 10 and 50, it's not me. If I'm mentioning const, I can't able to change that one. I'm getting warning because why? The action. Am I audible?
Yes, bro.
Yes,
Okay.
sir. Yes, sir.
So, but if it is in global variable, definitely you can't change that one. because it will store in the flash memory. If you're trying to change, it will give the program itself, it will crash. If you are using that OS environment, the OS environment stop that execution. If you're doing that microcontroller without OS, it will run, but you won't get that exact what you are desiring output, that you won't get. We will see that also. Let me run that one. See, I'm getting stuck. It's corrupted. Corrupted means it won't execute. Okay, you can able to see that because you are trying to changing that. If it is a global variable and const, that will store in the flash memory. You can't change that one. If you're trying to change using the pointer, it will give the somewhere. It won't work properly. That local variable you can able to change. Then why you are giving the const? That const, it's for programming perspective. So you have to understand it. Since it's giving the error, the programmer can able to find, okay, we can't change that in local variables. Fine, okay. So this is one case. Now we will focus on the other case. That is important. When you are using the const, now we are using the const for normal variable. Now we are focusing on the const variable in the pointer variable. Okay, so this is the three cases we have for the pointer variable. Now focus on this case. Let's consider I have the one variable int a. That variable is 10 value. Here I have the pointer variable ptr. The pointer variable is storing the address of a. Let's make it everything is the same data type. Address of a. Okay, this we already know that one. So this is not a const. Okay, let's make it this also const. Now I'm trying to actually try to understand what is that exactly. What does mean this const pointer? Normal variable, we know that one. Normal variable, how it's working in local variable and global variable, using how can we change that using the pointer, that we know. Now the constant is coming pointer variable. And I'm trying to store the, here I have to give the typecasting is easy. Don't worry about the typecasting. Forget about that thing. Okay, so leave it this one. I mean, don't worry about these things. We already know why we are giving that. Now I'm giving the address to the pointer variable. That's it. So how it will work? And please remember this one. If I'm giving the pointer const in between here, I mean here or here, it's not a problem. Both are same. Okay, don't confuse with that. If I'm giving normal variable or pointer variable, whatever, I'm giving const here or in between after data type or before data type, it's not a problem. Both are same only. But normally we are using this method. Okay, so now focus on this one. Normal local variable, pointer const variable. Now focus on this thing, how it's working. What is that? Exactly what is this? Just even if you don't have the correct answer, just try to give the answer. What I'm trying to do that. Just try.
Constant address.
Constant address means?
That variable address should not change.
Okay, address should not change. I mean, if I'm giving address of A, let's take another one variable that is address B. Variable is B. So I can't able to change the. See, for example, the pointer is now, this variable is now address of A. It's storing the address of A. So I can't able to change the address of A. Is it right? You're telling?
Yes, sir.
Okay. So anyone? This is one.
Actually, pointer is storing the address of A. You can't don't store the any other address like the address of B.
Okay. So same. What? Yeah. Same. What Sai said, right? Same statement.
Sir.
Anybody have the different statement?
Sir, from my side, sometimes you can also write strings, sir. Unsigned int start ptr is a string, sir.
Forget about the string. Now focus on these things only.
So using pointer variable, we cannot change the value of that.
Sir, it's value add operator, so can't we change value?
Then address we can able to change. That is your point?
I guess, sir, a const pointer is given, so like value add pointer is there, so we can't change the value.
Value mean which value? See, for example, here two concepts is there. Okay, let explain this all clearly, then we will come to that. So actually, if I'm mentioning here, well, let's consider this A, okay? A and B, both variable we have. So the A is a normal variable. Its address is 0 cross 0, 1. Let's consider 0 cross 0. This address is 0 cross 0, 2. Here we have the data, I forget, what is the data? 1040, okay. Let's consider this is the 10, let's consider the 40. Okay, so this is address. Now we have the PTR, that is a pointer variable. Here the pointer variable, forget about the data type and all. Okay, data type we already know. What is the data type variable is that you have to follow the data type. Now focus on only const. Okay, the PTR has one memory. Okay, let's focus on here. If I'm creating PTR pointer variable, this PTR, right, it's pointing this location, which means this location is 0 cross 0, 5. Let's consider 0 cross 0, 5. But this asterisk, it's pointing which value that PTR hold, right? Which value the PTR is a pointer variable. Definitely it hold the some memory location of some other variable. Okay, this dereference is pointing that location. So consider in our case, we are moving the address of A. So which means the PTR, this PTR, this name pointing this location, this dereference, since I already assigned the address, here its address is storing here, this address. Okay. So the dereference is pointing which memory location inside this PTR, right? That memory location is pointer, it's pointing, which means the dereference asterisk is pointing that location. Now, it's clear, right? Now the const where you are using, that is the important. So if I am using const, now I can able to see that I have the two variables, I mean two memory location. For both two memory location, I have the different assets. One is the PTR that is pointing this location. I can able to choose the two option. Either I can able to read or write. Okay, let's focus on the write operation. Only you have the option in write operation, whether you can able to read or write. Read operation, write operation, not read. Write operation, yes, or write operation, no. That you can able to do this in this variable. Here also we can do write operation, yes, write operation, no. You can able to do that. For in this variable, you have the keys, this one. For accessing this variable, this memory location, not variable, in this memory location, you have this asterisk, dereference key. So now, if I'm using const here, you guys are said two options. Some people said I can't able to store the address, which means here consider I am storing PTR equal to address of A. Now the PTR is holding 0 cross 0, 1. Next line, if I'm doing PTR address of B, then the value is here, it's changing. Okay, this is the overwriting. This is the write operation of this PTR, this location. Another one case, here I have to consider PTR address A I have. If I want to change this 20, asterisk PTR equal to 20. Then what is that meaning? The PTR already have the address of A value. Now I'm dereferencing this location. I'm changing the 20. That is another case. Here I'm writing, not here. Here I'm writing, overwriting the data. Write operation I'm doing in this location using the dereference. Same thing. If the PTR has the address of B, same thing. If I'm using this variable, I can able to dereference this location. So two location I have, two location write access I have. Using this, I can able to control this. If I am doing const, let's focus on this. PTR, this is the location, one location, it's pointing this. this you can enable to, okay, let's first try. You gave the two option you gave, right? Let's first focus on, you said you can't able to change the address of this variable. That some people said. Let's focus on that one, whether we can able to change or not. Okay, so first focus on A. Here I'm trying to change PTR equal to 50, then so now focus on whether I can able to change the address. Now it's in pointing in the A address. Okay, now I'm pointing to the B address. I'm trying to change. Initially it's a A address. You said we can't able to change the address because it's const. Let's consider whether we can able to change the address. PTR equal to address of B. I'm trying to change. Typecast, we have to do that since it's the address variable. Okay. Here you no need to do that because in microcontroller side only we need. When you are giving the address as a value instead of asterisk symbol. Say like I know that some memory, like how we are doing, the memory location, you are giving 0x400 or something. That time you have to give the typecasting. If you're using the asterisk like this, it's not an asterisk, ampersand, then you no need to do the typecasting. It's already know that things. Okay. Now let's focus on this one. If it is working, I can able to change the address. Here I will give the B because I'm changing the address of B. Okay. So let's focus on first thing. Based on my theory, can you please tell whether it's working or not? I said one concept, right? Can you please tell? Whether I can able to change address B.
Yes.
Others?
Yes.
Okay, so okay. What about others? Only two people, sir. Krishnavini sister. Krishnavini, am I audible or not? See, again, I'm requesting everyone. If you're not, I'm asking Krishnavini. So if you are not ready to listen,
Yes,
no need to
yes.
attend the class. So why you are taking this much time, Krishnavini, for responding?
Hello, microphone. I just few
Fine, okay,
seconds.
so Ankita, are you able to understand these things?
Yes, bro.
So what will be whether we can able to change or not? Ankita, I'm asking you only whether we can able to change or not.
Change, bro.
So how we can able to change? So how you are telling it will work? What is the reason behind?
Bro,
Actually, we are
Wait. Let her interact. I'm discussing with Ankita. Yeah, Ankita, continue. End of this concept. Wait. The end of this concept, I will explain everything. Then you have to take the class. Okay, so for everyone. Ankita. So the PTR, we are making the const here, and we will see whether it's working or not. Let's build that one. Ankita, please mute. Yeah, we can able to change the address. We are getting the B data, so which means we are getting the address. So now we can get my theory. The theory is we are not make the const the PTR. We are making the const which the PTR holding the location, that location we are making const. So which means now the PTR is initially address of A. Now the PTR is address of B, which means the PTR value I can able to change with different address. But the address, now the PTR is holding the P address. If I'm trying to change that location which is holding the PTR, that is a const. Dereference, it's not able to do this. Let's check that one. See here is a problem. So now I have another one question. So Mudasir bro, how can I this one you cleared, right? Are you able to understand, Mudasir bro?
Yes, bro.
Okay, so now I can able to change this data, but I should not change the address. How can I do that?
You don't want to change A address or PTR address?
No, I should not change this address. If I'm assigning some data, some address mean, I should not change that address like here, like how I am changing. Initially it's a A, now I'm changing B address, right? Like that I should not change. But I can able to change, which is this, for example, it's initially storing the address A. That address A initially has the 10. I can able to change that is a 50. So the overwriting is happen in that dereference location, but it should not happening in PTR location. Two location we have, right?
Yes, yes.
So how can I change it here? If I'm changing one thing in here, it will work. First explain how this section is working. How I can able to change the address, how I can't able to change the dereference one.
Because in line number 13, the address is you're making a constant, not the value. So that's why we can change the
What is actually address? What is the value?
You are making you are storing address in star PTR.
No,
Star PTR.
PTR.
PTR. So PTR has an already address. It's a variable which it has its own address. So you are making that as constant, not the value inside it. That's why you are able to change the address which is stored in PTR.
Very good. Then why I can't able to change the value? I think this is a little bit confusion. If you see this image, you can able to tell that properly. But since you're still still you're in confusion, I will ask somebody. Then you will get clear. Still, are you in confusion?
Yeah, yes, brother.
Okay, then Nadraj bro, can you please help me with this? Nadraj bro.
Hello?
Yeah. Can you help me?
Yes, can you hear me, bro?
Are you understand this concept?
Yes, bro.
Okay, can you please help me with this? So I want to change I have to change the address, here. I should not change the address. Initially, whatever the address I'm giving, I should not change that one. But I can able to change this memory location. So what changes I have to do here? Are you able to understand this concept?
Actually, program I understand, but the question actually what you are trying to say, I cannot able to understand this.
Okay, question I will repeat again. Before that, this part, are you able to understand why it's we can't able to access this memory location, dereference space, but we can able to change this here. That you can understand, right?
Yes. Let me tell you one time. Is it can able to correct me whether my understanding is correct or not?
Yeah, sure.
Line number 13 myself I say PTR points to a value. We cannot able to change the value through PTR, correct, right?
Yeah, why? I'm asking.
Since we have mentioned a constant, right? So we cannot able to change the value to PTR.
But PTR value only I'm changing here. This is changing the PTR value, address of A. Initially address of A, now I'm changing address of P.
The pointer itself is not a constant. So we can able to point to different variables. That's why actually we have point to different variable.
Good. Then what is the purpose of this const here? What actually it's working? We can able to change the PTR value mean. I mean, initially it's pointing the A address. If I'm can able to do the B address mean, then what is the purpose of const here? Okay, I want to know. So still, who all are have the doubt? Everybody is clear, or still anybody have the doubt? Everybody is clear. I can ask question anyone.
No, I have doubt like why unable to change value.
Okay.
I understood why address is able to change, but why unable to change the value? Not understood.
Okay, again I'm telling everyone, please listen properly. Okay, so consider we have the asterisk PTR. Forget about the const. The PTR, see for example, if you want to try anything, if you want to change the address, what you will do? You will write asterisk PTR equal to address of B like that you are writing, or PTR equal to address of B like that you are writing. Which one is correct for changing the address in PTR?
PTR equal to address of B.
We should not give asterisk PTR equal to address of B. The asterisk PTR is pointing which location?
Value of
value of the variable.
Value of the variable, which is which address is holding the PTR. That we have to understand the difference between this PTR and asterisk PTR. Consider the B only I am storing. The asterisk PTR, normal PTR, this location is this one, 0/05. Here I am holding address of B here, this location, 0/02 I am holding here. The asterisk in front of the PTR, if I am doing asterisk, that's mean I am pointing this location using the PTR address which is contained. Okay, so now the asterisk PTR means that is pointing this location. Normal PTR means that is pointing this location. So we have the two locations. Now, same thing while initialization itself. Asterisk, previously we have the some, forget about the data type. Okay. Asterisk PTR equal to some address you are giving, address of A, consider. Now the PTR is this location, asterisk is this location. We have the access for write operation for, you can choose, two options. Consider A only, now you are pointing, okay? The PTR as address of A, 0/01. Now we have you can able to access two addresses. Write operation, read operation, we can able to do that. It's clear? If I want to, changing the address of PTR, I can able to write PTR equal to address of A. It will change. I mean address of B, initially is A. Now it will pointing here. If I want to change this location, asterisk PTR equal to 20. It will pointing here 20. So I can able to do the write operation both location. Is it clear? Now, without const. Anybody doubt? Good. Without const, I can able to write here. I can able to write here. The const is, I'm going to restrict, what is that name? Restrict only, right? Is it correct? Restricted. I'm going to restricted any of one location for writing access. I'm going to remove the writing access, whether this one or this one. That is telling const. If I want to disable, disable the writing access for this location. So I have to write asterisk PTR, const I have to write here. Const asterisk, which means the PTR still this is considered 1, this is a 2. The one location still is in write access. But second location, which is this one, that is const. It's not a write access, it's only read access. Now, my question is, I want to make write access for location 2, this re-repression location. But I want to disable the write access for this location. So I think I am confusing. You clear or Okay,
Clear and
clear. So my see using this one, I can able to override this PTR, this location. So that's why initially I'm giving the address of A. I can able to override address of B. It's fine. It's here. You can see that initially is the one location PTR. The asterisk PTR is a different location. Okay. Now the PTR, that location initially I'm giving address of A. Since it's not disable the write operation, I can able to override that address of B. But this asterisk location 2, I make it the constant. I'm restricted write operation. So when I'm trying to do that asterisk PTR, it's pointing to this location. When I'm trying to do that, it's giving the error. You can't do that because that is a restricted. Same thing, I want to restrict this location, PTR location. I have to enable the write operation. Whatever this address is holding, right? That location I have to, so which means location 1 I have to restrict write access. Location 2 I have to enable the both write and read operation. So how can I do that? That is my question here. If I'm doing some changes, it will work.
After asterisk we can write. After asterisk we can write.
After asterisk I have to write here. So if you see here, you can clearly understand. The PTR, same thing. This one you will get a lot of interview questions. Definitely they will ask, and as well as while working in architectural program, you will see this const variable before asterisk, after asterisk. That time you should not get confused. Fine. This method one is there. So now we can easily understand the PTR. This location is now restricted. You can't do that. That is a const. You can't do the write operation. But whatever the value it's already holding, right? That is the address of A. That address of value pointing on location, that is this one. That is not a const. You can able to do the read and write. Let me check that one. So I'm doing like that. Now I'm trying to change the PTR value here. PTR is now const, but I'm trying to initially it's address of A. Now I'm trying to make address of B. Let's see whether it's working or not. It's telling I should not do that. That is a read only operation. Okay, so I know I can't able to do that. Let's try. Previously, we can't able to do that. The dereference changes. Now let's check whether I can able to do that or not. This address I can't able to change. Here I am. This data. Since I'm not changing the address, it's A only. Okay. Whether this location I can able to change or not, I'm checking. Here. Yeah, I can. You can see the A variable. The A value is initially 10, now it's 50. But the PTR address you can't able to change. If I'm trying to change B, address of B, it will give the error because of const. Now it's clear, right? Anybody have doubt?
Clear, Anna.
Okay. Now another one question I have. I want to restrict location 1, which means the pointer address, which is going to store the address, variable address. That also I have to restrict. And also location 2, dereference location. That also I have to restrict. What I have to do?
Put one constant before asterisk.
Okay. So is it will work? Or some problem is there?
It should come before uint 8 underscore t.
I already said, right? So you forgot about the uint 8. So both are same only. Why you are confusing with that? Say, forget about this one. Let first clear that one, then I will come here. Let's remove this one. Okay, leave it. First, let's remove it. Who said this answer? Priyanka only, right?
Yes, sir.
Okay. First, tell me how this will work. What I can able to do, what I can't able to do that using this concept. Do you have an idea or what? You keep on silent. Think of what happened.
This is like if the value pointed by the pointer cannot be changed.
Can we change the address?
Yes.
Okay, let's check whether can we change the address. If we can't able to change the address, the error will come here. Or else we can able to change the address, we can't able to change the location, that second location data, dereference location data, the error will come here. We will see. The error will come here. So which means we can able to change the address. Is it clear? Priyanka, is it clear?
Yes, sir.
Fine. Now come to here. What does the actual mean? Is there any changes?
This also the same thing will happen.
Same thing only. That's what I'm telling. So PTR is different. Now the asterisk only is constant. If you're writing const before this one, first itself I've said this one only. So writing const here before data type or after data type, it's not a problem. Okay. Same result only I'm going to get here. The error will come here only. Fine. Let's focus on this one. Actually, 3 cases we completed. There's a 4th case. What is the problem with this? Whether it's correct or it has some problem. I want to restrict both locations, the address storing location and the dereferencing location. Whether it's correct or it has some problem.
The value which is pointing to it is not actual constant.
I am giving right here const. For the dereference only, I'm giving const.
Yeah, but the A is not constant even it.
A means?
The value which is being pointed
that
to.
Is, forget about that one. I mean, you're telling this location it's not const, correct?
Yes.
That one only, still you guys are in confusion. I don't know. Forget about this data, okay? Using this pointer only, you can able to, making restriction or, enabling the right operation for both locations. Forget about this one, whether it's constant or not, okay? Using this PTR, I can able to make this one is the right restricted and this one as a right restricted. If I want to make this is the right restricted, I have to make const PTR. If I'm making before asterisk const PTR mean this could be this will be a right restricted. I can't able to write, but the dereference asterisk it's I did not mention the const, so I can able to write here. It's not a right restriction. Instead of 10, I can able to do 20 using the asterisk PTR. If I want to restricted right operation here, so I have to write the const before asterisk, const asterisk, then PTR. PTR we can able to change the address. Is it clear?
Yes.
Now my question is, I have to restricted both the PTR location as well as the which the PTR holding the location, right? That re-reference location also I have to make it restricted for right operation. So for that I'm writing like this, whether it's correct or not.
Yes, sir.
Okay. Correct. So we are making the PTR const, which means you can't able to change any other location in PTR. So first time what you are giving, that is, you can't able to change this one. And also you restricted the dereferencer, whatever the PTR is holding the memory location, that dereference location also now it's constant. You can't able to change that. First, let me change that location, memory location. Instead of A, I'm trying to give the address of B. It will give the error. Okay, so I can't able to change the address. Let me change now the PTR is holding the address of A. That address of A location I'm going to change. Instead of 10, I'm going to change 50. That also I can't able to do that. That also showing the error. So it's clear, right? Anybody a doubt? 4 cases we see. I think, yeah, we saw 4 cases. Anybody have the doubt in 4 cases? Is it clear? Fine.
Yes.
Ankita, is it clear? Can I ask any questions?
Yes, bro.
Okay, fine. So next topic, we can go to the the const is different thing is completed. Next, we will go to the volatile keyword. Before volatile, we have to see the different type of compiler optimization. First of all, let's understand what is the compiler. I think compiler, it takes so much time. Let's consider, assume this is not actually a compiler. This is the ID. Okay. Here, the compiler is different. Okay. So here, we can, in this ID, it supported different compilers. The compiler only is going to take care of the some build process. Build process, that also I need to take. Okay. The build process has some sections, pre-processing, and it's making the assembly. This is a programming, C programming. That C program is high-level language. That high-level language, finally it will go to the binary language, which means the X file. So that X file, in between we have a lot of sections, the parsing sections, pre-processing section, linking, assembler. So a lot of section is there. Everything is taken by the compiler. Okay, now this one, the ID is given by SDM. SG Microelectronics, that company is giving the SDM cube ID. But if you see the compiler, which is going to change your, convert to your high-level language, C language to machine language, which means the binary. That is compiler. That is provided by two compilers we have. Often we are using the two compilers. Anybody, in industry, we are using two compilers. What is that compiler?
GCC.
Anybody have idea? GCC, another one?
Tasking.
C-lang.
C language is not a compiler. C-lang, okay, C-lang, sorry. C-lang, lot of compilers we have. Now we will see that whether what compiler we are using for this one. This SDM, which compiler is using? Are you able to see that? Which compiler is using? GCC compiler is using. The GCC compiler is given by ARM. Okay, so if you see, it's not related to that SDM. The compiler is integrated with this ID. So whatever the machine, high-level code is converted to the machine code, it's taken over by the compiler. GNU/CCC compiler. Here it's provided by. For this separate document is there. So for making this we will learn when we are doing the bare metal, right? That time we will have to go through this document. We have to do that everything. Now just leave it the compiler. Okay, so the compiler has something. The compiler has some optimization level. So let's focus on what is the optimization actually, the compiler optimization. If you come to the GCC, since we are using the GCC, that's why we are focusing on this one. We have the 4 optimization levels. And OAS and OF, forget about that one. I don't have the idea about that. Here we have the 0 optimization level. 0, 1, 2, 3. Okay. No optimization. 0 means optimization. We don't have any optimization. O0. Optimization level 0. Optimization O mean optimization. 1, 2, 3. Like moderate optimization, full optimization, aggressive optimization. So if you see that optimization, see for example, this is a no optimization. If you come to the level 1, it's doing some little bit optimization work. Like, if you're using unnecessary lines, it will remove and something. Then if you come to the full optimization, it will do little bit higher than compared to 0, 1. So we don't know what actually it's doing, what are the things it's going to remove, what are the, if you come to the third, that is a advanced level. So compared to 1, 2, then it will, do the some optimization level, aggressive level. So which means we don't know what actually it's going to remove. That we have to refer the document. Okay. So for now, just to understand what actually the optimization is using. So before that, what is the purpose of optimization? So we can see that compiler optimization, the key point is improve the, reduce the source consumption, which means code size. So for example, if my code has the 10 lines code, okay. Some of the things is unnecessary things. For example, maybe some initialization I'm doing that is unnecessary. Without that also it will work. Like that maybe. Okay, some other things it can able to remove. Compiler itself it can able to remove. Okay, so it make the 5 lines code. Consider the 5 lines code. Since the 5 lines code compared to 10 lines code execution and 5 lines code execution, you are reducing the instructions. So the reducing instruction and the memory is efficient. So memory, improve. Storage, you are reducing the instruction size. So which means the memory efficiency is increased. Then and also if you are executing only 5 lines, the less power is going to, taking that one. So it's considering the low power consumptions, everything is coming to the optimization will take care. Okay, so main key is it's reducing the instructions. Okay, so which the optimization is suspecting it's unnecessary. Okay, we will see the practical example. These are the some common example I'm giving. But if you want to more about understanding this, you can go to the documentation and I think this documentation they're not giving about the optimization level. Optimization. They're giving some GCC command line tools that we are going to learn the time. That time we will see that one. Now focus on just to get some idea about what is the optimization. Okay, let's focus on our previous code. Okay, I changed a lot of things here. Okay, so mode A. So here I'm reading the data and based on the LED is blinking, fine. It will work. So let me actually hereafter for English batch we have to take another one project. I think I already have. So let me do that one. I open that one because go to the break. Please come 3 o'clock. Meantime, I will open that one. Please come 3 o'clock exactly. Can we start?
Yes, bro.
Sai bro, can we start? Puja sister.
Yes.
Oh, 1 minute. Website is not working. Anyone, can you please speak? Anyone?
Yes, sir.
Now it's okay. Okay, fine. Okay, so this is our code. Okay. Here, actually, we are going to see the first level optimization. Then we will see one by one. Register level. Properties. Then we have to go to the build process settings. Optimization. CCC compiler inside optimization. Now it's the option is 0, which means optimization level 0. It's okay. So first to go through that optimization level 0, how it's working. Then we will go to the next level optimization 1, 2, 3. Okay. So optimization level 0. Let's build a program. This program we already know. Each and every line we know, right? So how it's working. Instead of, let me write another 1J1 small logic. Okay. This already we know. Same thing. All the configuration here we are checking the bit RE 0th bit. Since it's a pull down, so always is 0. When it's coming 1, we are making the LED on and the LED off. That's it. I mean LED on. If it is not pressing, LED off. That's it. So let's build a program and see the assembly. This is
Semicolon bro.
Where? Okay. Now we will. I will connect the board controller, and we will check the disassembly. Disassembly we have to learn for ARM. Okay, we don't need to go to the in-depth concept. Some of the instruction we have to learn because so most of the architecture level concept processor side we have to focusing on the disassembly for debugging purpose. Okay, disassembly, go to the window. Window, show view, disassembly. Here you can see disassembly. Here. It's already open, I think. No. Disassembly. You can see we have the assembly code for all the instructions. Every instruction have the assembly code. We don't need to focus on this thing. Directly come to the while. I'm going to the breakpoint. I'm going to run the program. It came here. You can see that in our disassembly side, we have the assembly code for all the lines. In this line, value equal to, we have the some assembly. So if you come to the next line, if condition, for checking if condition also, we have the assembly. Then if what else what, we have the assembly. You can see that clearing this one, setting this one. 54th line, 58th line, we have the assembly. For this also we have the assembly. For this also we have the assembly. So each and every line we have the instructions, assembly instructions. All right. So the assembly instructions are the compiling process. First it's converting the assembly level. Then assembly only is converting to the machine level. Okay. So the assembly, each and every line, the compiler is generating the assembly. In code optimization level 0, in code optimization level 0, we have the total memory size, which means the injection size, which is going to store in the text segment. We have this size. We will learn all the segments, how it's working. These are the, this is assembly command that we will learn in bare metal concept. Here we have the everything. Forget about all the pieces, the stick X values, only focus on text segment. We have the 812 byte. Okay. In assembly 0, optimization level 0. Now I'm changing the optimization level to 1. I'm going to check whether that my program also it's working or not. Okay, I forget which option I have to give. Properties, sir. Properties. Okay. Assembly 1 I am giving. I will check which all the instruction it's working or not. So whenever you are changing the assembly things, you have to give the clean and build. Optimization level. So now if you see that final executable text format, it's totally changing. Around, if you see, around 40 byte, it's reducing because the compiler is doing for you some optimization. We don't know what is going to, what already is it removed or something, we don't know. It's removed something for you because the final output is previously 812 byte we have, now 768 byte we have. Let's check whether our program is working properly. Yeah, its memory is reduced, I know. Whether the program is working properly or not, we have to check. It's reduced something, we don't know what actually it's reduced. Now optimization level 1, okay. So I'm checking. And directly I'm coming here. This is simply, yeah, this line I have, 50 lines I have. Then let's go to the if part. The condition checking also I have. Here you can see the condition checking. Since it's, I'm not pressing that, it's going to the else part. Okay, let's press the switch and see the status. Now it's reading the data from that, that memory location. It's checking whether value is equal to 1. Yeah, now I'm pressing the switch. So it should go to the if part. Yeah, it's working. Every line it's working. My LED also it's working. That's good. So optimization level is perfectly working and also is reducing the memory. Okay, let's focus on the optimization level 2. My LED is also is working properly. Now focus on the optimization level 2. Okay, if you see the optimization level 2, it's reducing little bit. 68, now 48, around 20 byte it's reduced. It's good. Okay, so for 20 bytes reduced, it's reducing something from the program. We don't know which part is reduced. The compiler is removing something. It's which the compiler is, expecting it's not unnecessary. That part is compiler will remove based on the optimization level. In our case, we don't know what is removed. Okay, directly I will come here and put the breakpoint. You can see it's not stopping here. Let's see that assembly. Okay. Actually, we don't have the line here. Okay, we have the line here, value JR, that is reading, value checking, 1 minute. Directly going to the else, that's fine. Let me check my switch whether it's working or not. No, yeah, it's working. Okay, it's working. Okay, we have to go to the next assemblies things. This assembly also, these instructions are working. I mean, next optimization 3. Maybe you can't understand these things, what actually is doing. Writing simple program, I will explain, okay? First, just try to understand what is actually happening. But you can able to see that difference, right? That, memory difference, the storing difference. Now it's the top one. We don't have, that much difference here. So which means it's not did that any optimization. So same memory, maybe it will also work. Let's run. Did I change the optimization level? Did I change 3?
No, bro.
No. Okay. No, 3 only. This is 3 only. So for 3, okay, let's give the build, clean build. Same thing. Maybe this also will work. But I will tell what actually the problem will come. But in Tamil batch, we're facing on some problem. It's not the reading this value instruction. Since it's, it is assuming. But in this case, it's reading. I don't know why. I think now we are getting problem. Okay, let's come to the direct instruction. Let's stop in here. Clear. Here we don't have this one. Okay, good. Now we are facing the issue. So see here, I'm going to the next instruction. It's checking this one, whether the value is equal to 1 or not, it's checking. But the 5th line is not there. You can see here, the line number 50 is there, not line number 50. 51 is there. 50 also is there. Okay. Wait, my program is working or not, I will check. Now it's actually I'm pressing the switch. It is working.
Sir, but it should go into the if condition, right?
1 minute. Yeah, it's not working properly. Actually, some instruction is showing, but actually what's happening here, but we have to, spending some time to, I'm telling some theory, maybe it would be the problem. But we have to, for ensuring that this is the problem, we have to take some time, but we don't have enough time. Just understand the process, okay? So maybe what's happening, it's considering the default value. If you see here, every time it's going to the else part. So what actually it's initially is, taking this value, its default is assigning 0. Okay, so initially we are giving the 0. So it's or we can't tell that this is actually the problem. Maybe it's initially it's reading this value. That is since it's a pull down, that value is 0. So its default value is considered as the 0. Okay, then it's fixed. That is the value is 0. So it does not have an idea that value is updating from port A. Okay, it's fixed that 0. So always it's going to the else part because that value is predefined. Okay, but in this case, the assembly is there, but as we expecting, it's not working. It's going to the else part. even if I press the switch, whether it's coming to the inside the if or not. If it is inside the if, yeah, in this case working, but try to understand the logic. Okay, let me check. I'm pressing the switch. No, it's not coming in the if. Okay, even if I'm pressing also, it's going to the 0. So which means it's not detecting my switch press. So it's not getting the, it's fixes some default value is 0. So it's always is going to the else part. So that is the problem we have. Okay, so for solving this, you understand the problem, right? The problem actually what is actually we are facing a problem? The problem is either this 0 or initially it's reading this port, that is the 0, since it's a pull down. It's taking the pull down, default value, that is a 0. Value is always 0. It does not have the idea about it's going to change the value based on the switch. It's fixed the value is 0, that's it. So based on it's executing the only else part. It's not considering the if part. So always the value is 0. So that problem we have. So which means it's removing this line. It's the compiler suspect this is unnecessary line because the value variable is already 0. It's always the default 0. So it's not aware the switch is connected in the pin. Whenever it's I'm pressing, it may change. The compiler does not aware of that. So it's removed simply. So that's why the if it's not executing, even if I'm pressing the switch. Is it clear, everybody?
Yes, sir.
So how can we solve this issue? For solving this issue, we have to tell the compiler, see this variable, for more understanding, let me do that, one simple logic, then we will come to here. This is a macro, preprocessor, we will see that one. Instead of comment, I can do this one. In preprocessor section, we will check this one. I will explain this one. Let's write a small program, okay? A equal A, B, A equal to 10, B equal to 30, then B equal to 30. You can see two problems is there here. One problem, can you please tell what is the two problem? One problem I can able to easily tell. I'm using the B 2 times in unnecessary. Only one time is enough. That is a one problem. Same value as assigning. Even if it is the different value, it's fine. But I'm saying assigning same values is unnecessary. Different value also, which is the updated value, that is that is useful. In between, if you're giving 20 also, it's useless. Fine. Okay. So this one case. What is another one problem in this program? Actually, the program is this one is the program. These are the comment now. Don't worry about these things. Only these 5 lines are program. What is the problem? Another one problem.
Declaration and initialization we can both at same time.
That's not a problem. Inside the main I'm giving declaration, it's not a problem. That one. Another one issue.
Sir, while declaring only we can initialize the variable.
Why? You did not give like that in your programming. Only variable, global variable you are declaring and our local variable. You are simply declaring the variable. Inside the function you can override that variable, right? Why we have to give it by declaring you have to initialize? This
Every time declaration. Every time declaration has occurred.
No, I'm not writing inside the while. It's not inside the while. It's inside the main. Main also, I think I commented. Okay, let's write on the main. Okay.
Uninitialized variable.
Wait 1 minute. I should not comment the main here. Okay, again I'm doing same issue. Now it will come on this part only. This will come main. Okay, what you said? Uninitialized.
It has to be initialized to 0.
Okay, we can do that. Even though I'm initializing, some problem is there. Some problem, only one problem. One is the B I am declaring 2 times. What is another one?
A
Using
variable is
unsigned.
declared.
Okay, these variables are unused variable. Are you able to understand what is unused variable?
If they are unused variables, they'll be removed from the code when we optimize.
That's fine. That's fine. I'm asking. Are you able to understand what is unused variable? Okay, everybody, what is unused variable?
Does it mean we never used these variables for any operation? Like
Operation. Yeah, perfect. So we are just initialization. We are not using any other operations for like addition, subtraction. We are not using this one. Just our initialization. That's it. So let me go to the optimization level 0. Check all the variables is there or not. All the instruction. So optimization 0. Sorry, no. Sorry, none. Clean and build. Okay, if you see some warning is coming, forget about that one. You see the debugging window, you have all the instructions, all the 3 instructions you have, since it's not the optimization. This is the last one. If you completed this one, using volatile, we have to check, then we can go to the preprocessor stage. Then we will see. If you have the time, we will see the build process and other things, or else that we will plan next week. So now I'm going to see the deep disassembly section. Let's see. We have the 0 initialization. We have the 64th line, and 66th line also we have. Then what about the A equal to 10? Yeah, we have A equal to 10, B equal to 30 we have. Again, B equal to 30 also we have. You can see here 68, 69. So all the instructions we have. So which means the compiler does not doing the any optimization level. So I will directly go to the either can I go to the optimization level 1 or optimization level 2 directly. What I have to do?
Once.
Okay, now automation level 1 we are. Let's clean and build. So maybe in automation level 1 it will remove this peak, I think. Is only 1B it will remove. We will see. Maybe it will remove 1B, or else it will remove everything, because these are the unused variables. It's unnecessary as per the compiler's perspective. I'm going to run. Okay, you can see. Okay, let's run again. We don't have nothing, I think. Main function. Okay, it's removed everything. Wait, I will put breakpoint. No, it's removed everything. Nothing is there. So main function, inside the main function, nothing is there. Now you can able to understand. So why it's coming for loop? Here I'm giving the Fine. Anybody have doubt? It's removed. Everything is removed. Since it's unused variable. I expected the optimization level 1 will remove this one only, but it's removed everything because it's not using. Okay, so anybody have doubt? Now, I want the compiler should not do any optimization for that A and B. What I have to do?
Do some operation.
Okay, next.
Volatile keyword.
Volatile. That is the volatile keyword, I'm telling the compiler, see the compiler, this A and B anytime can able, I mean, it's going to change. You should not predict the A is 0 or A is B, whatever. You should not predict, you should not remove this A and B wherever I'm using this program. That is, even though whatever the optimization level, that is the volatile keyword. Let's run the program. Same optimization level 1. You know, right? That optimization level 1 itself, it's removed everything. Now same optimization level 1, I'm building the program. Let's check whether it's removed or it's all the injection is there. Since I'm giving the volatile keyword. Okay, this is assembly. You can see each and every line we have A equal to 10, B equal to 30, B equal to 30, initializations we have A, B, all these things is there. Still we are in the same optimization. I did not change the optimization level. Because of volatile, I'm telling the compiler you should not do any optimization. That's why it did not do for optimization only this variable. Is it clear, everybody?
Yes, sir.
Fine. Okay. So let's check wherever we have to use the optimization. I mean the volatile keyword. That is important. I think here I have the filter process. Okay, the volatile keywords. You have to use all the hardware register, like what we are using, same, that our input register, anytime it going to change. That all the hardware registers you have to use the volatile keyword because it's anytime it's going to change. Okay, so if you see here, see that one, what is that actually? What they are telling? First focus on this one. Next we will come that volatile. What they are actually telling this here. Asterisk const status register. That is the register name, one pointer. Okay, they are assigning some variable, some address. Okay, so what actually they are telling?
Address is constant.
Address constant.
Address is constant, but data you can able to change, or from hardware side it's changing, or you can able to change because they are not giving here const. The address is the constant. You can't able to change this address hereafter. Once you initialize, that's it. Okay, so now we can able to understand what is this one. Previously we have maybe some doubt. Okay, fine. Now the volatile. The volatile they are telling. This is the constant. Okay, the both are different, so don't confuse with that. The status register is constant, which means the address is constant. The address pointing on location, right? That location may be changing. Anytime it's going to change. That is why we are giving volatile here. Asterisk. After asterisk, we are giving the volatile. Even the volatile is correct. It's okay with if you're writing before data type or after data type. Here, if I'm writing unsigned unit 32 volatile star also, it's fine. It's clear. Fine. Okay. So now, and also you have to write the hardware side. You have to write the volatile keyword and interrupt ISRs. The ISR anytime it's going to change. Say for example, in main function you are using some function. For example, declaration I'm giving the false, which means 0. In main function I'm giving it. If it is not 0, it's doing something. But if I'm doing the compiler optimization, compiler does not know it's changing anytime it's changing in the ISR. If I'm pressing the switch or whatever, it does not know. So it simply remove. If you simply fix it, okay, the flash is 0. So say always instead of this one, it's predefined is 0. Like that it will do. So maybe whatever the variable you're going to use the inside the ISR, that should be in the volatile. And also some shared resource memory. So multi-threading. So if you are RTAS, 2 threads when you're using the 2 thread going to use the one variable. That is a shared resource. I mean shared variable. That shared variable you have to shared variable or shared memory, you have to make it the volatile. Fine. So this is a simple introduction of the volatile. Next we will go to the What is the next thing we planned? I forgot. What is the third one? Preprocessor. Okay. Third one is the preprocessor. Maybe within half an hour I will complete that one. 4 o'clock we will leave. Preprocessor. We have the some different types preprocessor. First, let me understand the preprocessor. What is the preprocessor exactly? If you see here, we have some stage of building process. I mean, okay. So here you see, if you're writing the C, C++ or whatever, the .h file, that is the source code. The source code is first to go to the preprocessor stage. The preprocessor stage, it's all the expanded macros and including the header files. Whatever the preprocessing you are doing, we have some list of preprocessor. I will tell. So whatever the preprocessor you are doing, everything will resolved here, and it will generate the initially is a .c or .ccp or .h. Now after preprocessing, it will generate the .i file. Then the compiler will come. Please remember the compiler tool, that is different. Compiler is different. The compiler tool has everything. The GCC compiler I'm telling, right? That has everything. Preprocessor, compiler, assembler, linker, everything is combined of compiler tool. That is the GCC. This compiler is different. This compiler, preprocessor, the .h file, it's changing to the assembly, generating the assembly. All the C file, it will change it to the assembly file. This compiler. Okay, this compiler will tool the .s or .asm file. It will generate. Then we have the assembler. The assembler will generate all the .s file to, assembly file to object file, machine file. .o. If you see, I have the four .c files. So like main.c, then led.c, 2 files. Consider main.c, led.c, 2 files I have. All the main.c, for main.c I have the main.i, led.c I have the main.i. Then for assembler also main.s I have, led.s I have. That object file also I have the main.o and led.o. Then all the object file, including your, including that some SDDIO, SDD int, everything is linking. All the object file and all the, library files. All the object file, library files, linking in linker. That linker you can able to control using the linker script. And make file, this all the automation process you can able to do the make file. That we will learn in embedded, bare metal concept. Now don't go to that. I'm not explaining the build process now. Build process I will explain later. For pre-processing, I'm giving there some intro. Then after linker, we will the only one X file. That integration of all, let's say like our main.o and led.o, like that. If you have the 1000.c files, 1000.o file will generate. The 1000.o file will merge only single executable file. That is a final X file. In PIC class, you are flashing one X file, right? That file. That one is a taker of the compiler, the GCC compiler, not this one. This compiler is different. The compilation tool will take care. Okay, now we will focus on the only preprocessor. What are the preprocessor is there? How it's working? I think type they did not give properly. Let's see. Arch include is there, define is there, then define. They're not giving properly. Let's check other one. As define, okay. As define undef, okay. What about other things? Here also they are not giving properly. Okay, I will tell that one. What are the things we have? You can see all the optimization we are reducing the memory that we already see, right? Fine. So first we have as defined. Then we have next one, hash include. So then, anybody, what do we have in preprocessor?
If define.
If define. If define means we don't have any if define.
If
We have
def.
the def
Else.
and no
Else
else
if. Else
wait,
if.
wait, I think you are confusing. So is this if def is different, else that is a different, elif is different. That elif one is coming, this if. Here only we have to come after elif
And def.
else. Then we have the if and def. I mean n def. Then we have the if not if def, undef, undefined. Then we have the error, warning. Then we have the
Pragma.
Then end if. Then we have and condition checking, defined. Actually, it comes if defined. That is one case. But it is a little bit complex case that we will discuss later. So all those things is there. First, let's focus on the define.
Sir, what about type def?
Type def is different. It's not a preprocessor.
Okay.
Type def and that is a user defined data types. That's a different.
Okay.
That's not a preprocessor. Which all are the mentioned in hash. You can see some of the things mentioned in the hash, as defined, hash mac include. This if and our if is different. Our programming if is different. This if is different. Our programming, what we are doing, that if else condition, that is different. That is a programming part. This is a macro. I mean, sorry, not macro. This is a preprocessor. And that stage you have to understand. So these are all the preprocessor what I am writing. Everything will, before going to the compilation, it will result here. All the things. For example, if I'm doing the, I will tell. So hash if 0 means that block fully removed here. That what are the commands you are giving, right, in programming? I am saying to write command properly. That all the commands will remove here. Okay, let me go first. Step by step. First, we'll focus on the if def. That one, define macros. Okay, so first one we have the define, as define. So I think this thing already some people are know. I think so. Maybe whoever want to leave, you can leave 1 minute. So who is going to take the attendance? Anyone? Anyone, can you please take the attendance?
I will take that one.
Okay. Once she said she completed the attendance, whoever want to leave, you can leave. Where I am going to see what are the mentioned, right? That thing I am going to we are going to see next half an hour. If you want, you can stay. Once she said she's completed the attendance, you can leave. Okay, as given, there is a macro we already know. So say consider I'm giving some name under this one. So if I'm giving, if I want to print that max printf underscore let max. So what will be the output I'm getting if I'm printing it?
5.
That we already know already. So, but here we have to understand one thing. This is a pre-process, not your, for this, it's not going to create any memory for this storing this 5. So for example, instead of, and also this max we can't able to overwrite. This is a const. Max equal to, if I'm doing 10, it will get the error. Okay, so the difference is this max and this is a constant. Then what is the difference between this const int max equal to 10? So both are const, but this is a preprocessor. So it's it's resolving. It's not creating any memory for this 5. It's automatically replaced this location when it's doing the pre-processing stage before going to the compilation, assembling everything. But here it will create the one memory for the flash inside the flash memory that we will learn in later. Just focus on this one. This is actually pre-processor. Now if I build, I will get the 5. Let's and we can use the this is for the little so like some operation like a function. So let me do that one addition function. X comma y. Here I can pass the values 10 comma 5. So what would be the answer if I'm printing? Sorry, I think here I have to give the x plus y. This is actually the function. Okay, so if I'm passing the argument 10, 5, it will store the x, store the 10, y store the 5, then it will add, then it will come to the, if I'm printing here, it will come, 15, it will come. So is it right? If I'm printing, I will get the 15.
Yes.
Anybody have doubt? Okay, Lakshita, is it completed?
Yes. Yes.
Okay. Okay, whoever want to leave, you can leave. Fine. So I'm going to build now. Let's focus on, I'm getting the 50. We already know this thing. It's not new for us. 50. But here we have to focus on another one thing. What will be the answer? Now I am going to get 15 into 3, 30, 45, correct?
25 will get.
Okay, 45 or 25. What is the answer? I don't know. 45 I'm telling. So because it's going, then it will come 15 to 3, 45. So if somebody is saying 45,
25.
25. What about others?
25.
Okay, so why 25?
Because the value is just replaced like that. So it will be 10 plus 5.
Very good.
Directly.
So
that's 5 into 3.
In preprocessor section itself, it's not doing any compilation, addition, subtraction, anything. Preprocessor section itself, it's just to replace that whatever we're passing, 10, 5. It's replaced 10, 5 here. So final, our execution time, it will come like this, 10, 5 into 3. So 5 into 3 is 15, then 25. So like that it will work. So if I'm printing also, I will get 25. You can easily see that one. It's an entry question, this one. 25. So, but actually I'm not expecting this 25. You should not write like this, So whenever you are doing some operation in macro, you should follow bracket. Without bracket, you should not write. That's not a good practice. We saw the problem, what we faced here now. It should become 45, but we are getting 25 because that's the problem. You should always, if you're doing some operation in macro, you have to do it like this. So now what will be the answer?
45.
45, because the whole thing will now come replacement. So whatever you're giving here, see, even if I'm not giving the semicolon here, I can give here. Oh, I will see that. All those things, it's replaced here. Same with the data, 10, 5, same thing. Now will come the 45. There is a good practice. You have to always use to the bracket. Without bracket, you should not write. Okay, we are getting the 45. Let's see this one. I said, right, that semicolon also you don't need to give. So normally if I'm giving, it will give the error. Without semicolon, how it will work like that, error will come. Okay, so I'm giving semicolon here. The semicolon also, it will come here. Right, okay. I think I should not give Wait, I can't, right? It's a replace.
Bracket close on 10th line.
That is for semicolon. Okay. It's replacing with semicolon. What's the problem?
Brackets, sir. 10th line bracket.
Okay, let's do only one thing, because we understand that thing, right? So max, let's change to max equal to 5, that's it. So I'm not giving the semicolon. Bracket we need. Okay, good. Fine. Sorry. So bracket semicolon. So 5 bracket semicolon. So the 5 bracket semicolon, it should be replaced here. Let's see. You can see it's working. So it's simply replace. That's it. Without bracket, it won't work. But here I'm giving. So it's simply this, all the things what I'm giving, it's simply replace here. Okay, it's clear. As defined is clear. Now we will focus on the other things. If def. So if def, it's nothing but like if you want to remove something. Remove means, say for example, some DSP you are using. This automation side is really important. If you're using same DSP for different microcontroller, I mean some structure. Almost, maybe we will see when you are seeing the bare metal, that time I will explain. Consider some code is there. That code is act as that it can be used for 2 different microcontrollers. But which microcontroller you have to use based on it, it automatically it changing. So like that, for that we are using this one. So like if of 0, it won't work. So then, so for example, else normal our if else only, but this will working in pre-processing stage itself. Okay, our normal if else if it's working in normal programming stage. I can see the if of 0. So it's look like a command. Then pre-processing stage itself, it's removed. This part only it's going to upload the a final text file, text file. Then if I want to these things, if I'm giving 1, it will work. Now this is are the commands. It will remove in pre-processing state itself. Final execution, it won't be there in memory. If else end if is then another one case is elif. So the elif I will tell another one concept. Before that we have to see that if def. If def, when you are defining one macro, that time the if def will work. So as define demo. So if I'm using if def, if you are defining any macro, then it will work. You can see. If you're not defining, it won't work. So this is also it used. I said right. So if you are going to use one same program file, that program file has the 2 different sections for working 2 different microcontroller. So if you are using one microcontroller, you have to define that macro. Then what are the, say for example, 1000 line I am writing here. But 500 lines are same, consider the same program. This part working when I'm using some microcontroller. Okay, this part will work when I'm using the different microcontroller. Okay, so for that I have to use this macro. If in that microcontroller, that microcontroller name is demo, consider. If I'm enabling that microcontroller, this part will work. This will, they are doing the automate. Automate means, let's consider. Here I can able to do that one. Properties. You can see the preprocessor section one is there. Preprocessor here. Preprocessor section, you can add that one. Add demo. If I'm adding, its default is add. You can see, and even if I remove also, it will turn. Wait, I think I need to build. Some of the programming you can't see that macros, but it will work. So in that case, in some properties option, they defaultly they will enable that one. Whether the build is successful or not, I think I have to give the clean build. Okay, maybe here it's not showing, but it will work. Let me check whether I give properly or not. Okay, so we have the only 10 minutes. Like that, we have the option demo. If I'm giving it demo only, right? Yeah. Then why it's not working? You can add this define here, but I don't know why it's not working. check this also, okay? Using this also, you can, without adding here, we can able to do that one. This is a define. Undef we have. So for example, I need to undefine this one. Already defined one, I have to undefine. So for this, hash undef demo. You can see here I'm defining, but next I undefined that one. So now it's an undefined. So it's it's considered as the undefined. Anybody have doubt till now? So we saw define, include we know already. If def, if if we have to say, okay, let me see that. Else we see if undef. If undef is a option of this one. Now consider this this demo is I'm not defining because already I defined, but I did the undefined. So the demo is not there. So if I'm giving undef, if it is not defined, then execute this one. So undef. If it is not defined, it's executing this one. You can see this is the if end if. If end if, okay. Then we have the other one. Undef we already saw. Error warning we will see. Pagma, okay, end if we see as defined. This is a little bit tricky. Tricky mean consider two concepts is there. So my case is the demo should define, okay, and test. It should not it should not define. When the demo is defined and the test is not defined, that time only this block will execute. For the condition checking purpose, that time we can use the define. If defined demo and define test. Is it right? What I'm writing? I said when the demo is defined, test undefined, that time it should work. The case is correct. What case I'm writing this is correct?
No, it is both defined case.
Then how can I change this one?
Undef test, undefined test.
Undefined, I don't know whether we have that macro. Let's check one. Yeah, I have. Okay, good, super. So another one, instead of undefined, another one. Normally in programming we are using, right? Correct. That's also telling undefined. Okay, fine, good. So using that operation, so let's consider any of one it's working. That time also it should work. Any of one this is true, then it will work. Now what I have to do? See, in this case, both are is true. Consider now it's both are, this is false, but that's why we are not executing this one. In my case, any of one is true, it's feel free to execute this line.
Use R operation.
Okay, good. Fine, now it's working. This is a false, this is a true. So this condition we can able to do. And the error and the warning, that's if you want to do mention error, you can do. So for example, let's consider this also in, please remember, this is also in the pre-processing stage. Pre-processing stage means when you are building the program, that time itself you will get this warning or whatever the error. So consider if def max is defined, you will get some error, some warning. Like let me first try the warning. Warning. Just to check, okay. Then end if. That's it. I'm going to run. You can see we are getting warning, but the code will run. Okay, because that is a warning, but we are getting the warning. You saw, right? We got the warning. Now I'm making the error. You see that warning we are getting because the max is declared. Now if I am undefined this one, now the warning won't come. You can see the 0 error 0 warning because now it's not defined. Next we have the another one, that is a error. Now you can't understand any, most of the thing, just get some idea. Okay, maybe in future if you started working on that time, you will get some idea. Okay, we already learned like that. So error, it won't run the program. It's printing the error. Check. These are the pre-processing stage. Okay, it's not running stage. You have to understand that one. Pre-processing stage itself, it's checking. Okay, fine. Anybody have the doubt on the pragma? We will see maybe next class in structure padding we will learn. Yeah, next class itself. The structure, lot of things. Structure means bit field. Wait. Bit field we are going to learn in next week. Okay, so next week I think maybe next week we are started to touch some little bit advanced concept. Next week onwards. Okay, most of the things we will learn next week new. After next week we will learn everything new. Some people already know. I'm telling. Most of the people started to learning new concepts. Okay, so fine. Anybody have the doubt? Anything? Do you want to discuss?
Preprocessor is not consuming the data memory, then it's consumed the code memory.
No, it won't consume the code memory also. Code memory means that code memory means you were talking about that flash side, right? Flash memory.
Yes.
So flash memory also the const variable will occupy, but where that preprocessor memory will create. Memory means it's not creating any memory. So for example, let's try to understand this max, right? That for max we are not getting any memory allocation, but this one memory allocation, if I am using the const keyword max equal to 5 mean, that will store in the code memory, which means that flash memory, definitely. But the preprocessor max 5, it's not allocating any memory location for in code memory and RAM for this max. But we have to understand, then if it is replacement, this data 5 is replacement here. For example, in print I'm doing, right? Here I'm telling it's in pre-processing stage itself, it's replacement. Then if it is a replacement, where that, somewhere the instruction it's stored, right? Here the pi is constant, it's replaced. So this thing we have to understand where it's, storing. That maybe wait 1 minute. Let's make an. It's not variable, just I'm just typing. Okay, here they're telling that that value is replaced before compile the code everywhere. Wherever I'm looking PA, it's repairing, but the final executable where it will store. Okay, let's consider. How can I ask the question? I'm not getting that question. How can I ask? Then where that,
I think the instruction itself is directly replacing with the constant value.
Yeah, that's my question. It's how can I ask whether the constant variable is fine? It's directly replacement, but the replacement instruction where it will store. Whether it is a
Yeah,
RAM side or that we have to understand.
Yeah, the instruction it is called in the text section only, but in the instruction set, like we have to give an argument, right? So that particular it is taking like the opcode, it will take the constant value itself. The 5 value it will the instruction 5 value take will be will be taken. Like it won't be reading any another memory location.
No, I'm not getting. So see, consider in programming, I am storing here that. So in preprocessing stage itself, the 5 is storing here, correct?
Yes.
But where this injection will, even if it's a constant, it's fine. Say, for example, if I'm using the const of max equal to 5, const into max equal to 5, that 5 will store, that variable will store in flash memory.
Yes, that there is a location for that particular max variable. But here, this preprocessor max variable, there is no any location. In the instruction itself, the 5 value will be, like in the print, there is an, like you showed like that opcodes and some assembly instructions, right? So in the assembly instruction itself, like the 5 value will be get replaced there. Like it is not like reading from a specific memory location. It will be directly injecting that particular 5 value into that instruction. We have that.
Fine. Okay. So yeah, I understand. Your sister, you also get some idea, right?
Yes.
Fine. But we know we have to confirm that. Just yeah, it's correct only. But ensuring getting more idea, just everybody, so take this one. Where that actually showing how that injection are working. So everything is check. Maybe next week we will if anybody have the idea, we will discuss in next week this week. Fine. Anybody have a doubt? Anything? No, right? Fine. Okay. Thank you.
Hello.
Am I audible?
Yes,
Yes, bro.
Yes.
Okay, let's do these things. That one code optimization without a controller, you can't check that one. Do one thing. So all the 4 cases you have to practice. 4 and the constant cases. 4 constant case. You have to practice and submit the console output. C programming. It's easy only. Okay. Next, all the these macros you have to practice. Not macro, preprocessors. All preprocessors you have to practice and submit the console output. It's easy. Within half an hour you can able to do, because already I did everything. You are going to practice. You are going to submit the console. The main task is, it's not a task actually, study materials. I will share. Structure, you have to learn in-depth concept, because without structure you can't learn the bit fielding. Next week we are going to see the bit fielding, structure alignment, a lot of concepts, the structure related. Architecture side we are going to debugging, and assembly side if I'm using structure padding, how that assembly is different, how much injection is executing. A lot of internal concept we are going to learn using the structure. So all the C programming concepts, structure related, you have to learn. That is a big task. That's why I'm giving the small one. Today itself, please complete this one. It's an easy only, right? So the case, I already know that just maximum within 30 minutes you can complete. This is taking more time. Okay, please make sure to learn everything properly. Fine. Anybody? Any doubt?
Anna?
Tell me, sir.
Const variable, if we declared in globally, can we change using the pointers?
No, you can't change. We did, right? Experiment itself we did, I think. It's getting anger.
Why? Any reasons?
The reason means it's a flash memory. The flash memory means that is a read-only regions. So you can't change that one. If I'm in global variable, I mean local variable, it will store in the stack side. So there you can, getting the memory and you can change that one. But when it's initially, if I'm going to the global variable, that I mentioned the const, we have the one segment. I will tell that when we are learning, bare metal, or maybe next week, I will tell that segments. One segment, we have the .ro segment. So the .ro read-only segment. When we were mentioning the constant, that variables and all move to the read-only segment, the .ro segment. That RO segment, using that, that variable address, you can't access that one. If you're trying to access, right, if it is a OS, it will crash. But in microcontroller side, you can't able to do that properly. It won't work simply.
Okay.
Anybody? Any questions? Fine. Okay. Thank you.